All right, so let's start. Hello and welcome everyone to today's webinar, How to Quickly Migrate Your Legacy Workload to Cloud Native. I'm Christine from Kubernetes, and I hope you are all doing fine despite the pandemic and the new lockdowns. I think what has become very obvious over the past few months is that with the pandemic, businesses have an even higher pressure to digitize their products, services, processes, and everything, but many still lag behind in their efforts. And that, you really need to start going cloud native now. But it's not always that easy, in particular if you have like old legacy infrastructure that you want to modernize. Therefore, today we will walk you through the three main approaches to modernization: lift and shift, augment, and rewrite. And before we start, two short informations. We are recording this meeting, and so if you need to drop out early, no worries, we will send it after the webinar. And we have a short Q&A session after the presentations. So if you have questions, just drop them in the chat window and we will answer them either straight away or at the end of the session. And with this, I want to hand over to today's speakers, Sebastian and Malte.
Yeah, thanks, Chrissy, and welcome to our webinar. So let's get started. So let's do a quick introduction about myself. I'm Sebastian Scheele, co-founder and CEO of Kubernetes, and with me in the call today is Malte. Do you want to introduce yourself?
Yeah, sure. Thank you. So my name is Malte Meckhoff. I'm solutions architect here at Kubernetes, and I'm supporting the customers during their journey to cloud native with our product portfolio.
And yeah, today we want to give you some insights, what you can do and how you can migrate your legacy applications to cloud native. But before we start with this, potentially for the ones who don't know us in detail, so where we are, Kubernetes, we are fully focusing on Kubernetes. We are doing several things. On the one side, we have two main products called Kubernetes Platform and Kube1, which helps you to manage Kubernetes cluster at scale. Additional to that, we are also providing professional services and trainings to our customers, so how we can help them to migrate their workloads to Kubernetes. And this is what we want to talk about today is really about our experience, what we did in this time. And so we're currently a bit or close to 60 people with a quite distributed team and having a lot of experience with working with customers in a lot of different industries and different areas, and help them on their first steps of their cloud native journey, but also on a longer journey. And so this is one of the knowledge we learned there. It's still hard to migrate your workload. And what we're really seeing is like when we're looking into especially enterprise IT adoption, typically the enterprises are behind the rest of the world. So enterprise are, of course, quite often much more interested in what is the return on investment, but also there's much more challenges in adapting new technology, because it's not only about the technology. Quite often you also need to change your processes, and potentially also people needs to be trained, and this takes quite some time. I think this is also true when we're looking into cloud native startups and really IT innovators were like the first adapters of Kubernetes and cloud native. But now we see also more and more that bigger enterprises are using it or start using it and picking it up on the workload more and more. But why the enterprises are driving into this? I think one of the interesting factors, of course, in a lot of cases, the business wants to have more with more or less effort, and especially with the cloud and SaaS offerings, now also the business gets used to it more and more, that they easily can start services and doing stuff on its own. And this also creates pressure on the IT, and that they need to deliver features faster on lower cost, and so that they really need to think about how can we build a system that not every business is doing its own, and we have a zoo of tools out there which is not centralized, controlled, and managed in a way so that you can still know, okay, what you're doing, and but still have the capabilities to be fast on this and to be innovative on this. And I think one of the drivers is also the business expectation is changing more and more. I mean, we now all know it all from like our mobile phones. Everyone is used to quickly install an application, try it out. Things are true also for SaaS offerings. And if you're looking still in the spendings of classical IT, a lot of the spendings goes into maintaining the portfolio, and only like 30% is going really in investing in modernization of this portfolio. And I think we need to think about how can we speed up, and this we had it in one of our last webinars. We believe into cloud native can really help this adoption and be faster, be more agile, and deliver faster success to the business, but also inside of the organization, but without losing stability inside the platform, for example. And yeah, so what are really areas where the CIOs and CTOs are looking into is, it's on the one side, they need to look into how to balance between maintenance and innovation. So of course, there are still a lot of systems which are not cloud native. You still need to maintain them. You already convert some stuff into cloud native. You also going on things, some systems you want to go faster, on others you say, okay, that's my backbone, I want to have really stable release cycles, we cannot go so fast. But for example, for your web application, you say, okay, I want to do daily or weekly deployments, or several deployments per day. On the other side, what we're seeing is also companies want to reduce their vendor login, and I think that's a big value proposition for open source, so that you're not tied to one vendor. A lot of customers are using multi-cloud strategies, not going only to one cloud providers, running also cloud native workloads on-premise in their own data center, and want to really increase their efficiency with a lightweight tech stack, so that's easy, first of all, to onboard new people on this, and but the development, everything can be driven in a fast way, and you can quickly try it out, R&D new features, and see where it's going, and so that you can really remove technical debt and risk from your application, which was built potentially 5 or 10 years ago, and how can we get this into a modern world so that you can really adapt agile methodologies, but also like DevOps approaches or site reliability engineering approaches, so that you can go to the cloud, but also with the same approaches you can run it in your own data center. And one topic which is coming up more and more is also the whole edge computing, so potentially that you can run Kubernetes in your fabrics or in your shops, and how using the same principles you do it for your cloud and modern development, also in this kind of development. And I think that's really a big value proposition for why you should modernize your portfolio. On the one side, really want to have the flexibility to easily experiment, testing ideas out, seeing if this is working. If this is working, great, then you can continue and developing it. If it's not working, no problem, because potentially you only invested 1 or 2 weeks for the development, throw it away and start with a new idea. But also to build more incremental changes, really lower the change failure rate. Instead of having one big release with a lot of features in there, shipping each feature individually, so that you really know, okay, what I changed, how I changed this, and how can we adapt this. And of course, with this also having more frequent deployments, not only deploying once a quarter or even less, deploying weekly, daily, or several times a day, and having a system which is really built for recovery, because in the past we built systems that they are not failing, but in a lot of cases it's much more important that you can fast recover, because we know all systems will fail, and if you can recover fast, and potentially if you can recover your system in a few seconds, and you can run it in a HA style, then it's not a problem when something is dying for a short time, and you easily can respawn it. And so having then also the possibility to really get higher performance, because you individually can scale different components of your stack, and really have short time or shorter lead time, how you can deploy it and when you can deploy it. So, and this brings all together really improving your overall quality of your product, and also getting more features out to your customers. And what we think and what we're seeing is, of course, like, and I think COVID showed this quite good, even that's the worst what could happen is, if you are not like having IT which is really built for the demand and also for future demand, so that you easily can scale this, you can get into problems. And so what we think is really, you really must stay ahead of the demand, and building tools also that if the demand is coming, you can easily scale, and also that you can choose your infrastructure, and going down from monthly and yearly deployment approaches, like for example with waterfall approaches, and more to a much more agile approaches, where you're building potentially microservices or some bigger services, but which they're running, and in best case running them in containers, and running them in the cloud or hybrid, so that you can connect this, and bring this this can bring more and more value. And so in the next step, Malte will explain you what could be approaches, how to do this.
So thanks, Sebastian. So I would like to talk in my part about release cycles, about what is a monolithic release, or what are microservices, and what are the different approaches to modernize the application to bring it more to cloud native. So a typical release cycle for a monolithic application is traditional, following well-defined steps. So first of all, there's always a release plan for the whole software stack. So where every developer is getting a certain task where he has to work on it. And when every developer has finished a certain working package, the certain feature will be, first of all, integrated. There will be several Q&A tasks, and hopefully, if they are successfully done, in best case, there will be even a user acceptance test. From a waterfall perspective, when all of this has been done, which can take in certain application stacks even more, 3 months or something like this, it will be handed over to the operations department, which will replace the old release with a new one. I think everyone knows it, how this has been done in the past. What's important, just for the speed of the innovation, is there are 2 possible stages where potentially bugs will be identified and reported back to the development. Either the developers itself during the integration, or the Q&A department, or user will find a bug in the software. And after they have found it, during integration testing or user acceptance, they will bring it back to the development department. Or the other way around, the operations team, which is even worse, is finding a bug during the deployment of the new software. In both scenarios, the bug reporting goes back to the development, which first of all needs to fix the problem. and the process will be restarted. So first of all, integration, Q&A, potentially UAT, user acceptance test. In the second scenario, in this case, it is much more critical as the ops teams may not be able to roll back to the old release, or is facing an outage after the maintenance windows is closed, or they have to rescale again a new change request for the new upgrade of the software. In both variants of this scenario 2, the process of releasing new features with a new release is slowed down due to this waterfall process, and is as well causing at the same time a very bad user experience due to the longer or more maintenance windows which are needed for the software itself. But if we are now looking on a modern software stack, which is based on Microsoft, we are able to see that there's a release plan per microservice. So in our example here, we still have the core of the application based on Java, and the core group is still working in a distributed fashion. So there are still 2 developers which are working on it to bring new features and functionality into the core. But what is new here is that certain elements of the service or application has been moved into, in this example, Node.js, maybe for the web application part, and as well introducing new features in another department or in another squad in Python for machine learning, like for a recommendation engine or other fun stuff. So the big advantage with microservices built on containers, as an example here, is that each of the microservices itself can be developed standalone with its own release plan, and therefore can be seen as a separate. Well, what we can see is that a separate feature can be created and which can be rolled out into production here. So in these scenarios, the guys which are responsible for the recommendation engine based on the Python code have finished their work and can release a new version of their software piece to the production without interfering with the core of the services. So that brings a lot of faster innovations into the software stack. So when we are talking about modernization your portfolio in a structured approach, we see that there are 3 main approaches. You can follow these main approaches here. Either what you maybe know, lift and shift with containerization of existing components, augment where you enable capabilities via new layers, or complete rewrite of the entire software. I think at least lift and shift knows a lot of people. Rewrite, everyone has heard about it and was thinking about, oh, that's very expensive. Or maybe there's augment. So let me just introduce you into the 3 approaches, how we see it, and what would be maybe the best way for you. So lift and shift. In this classical lift and shift approach, the components of the service will be moved into containers on any kind of path solution, whereas the data, external configs, and integration points will still remain, I think, quite known. What we can see here is that the components of the service, and this is just an example where we just split it into UI, the business logic, and the persistent data, has been moved into containers, and each component is able to scale out on demand with containers, and afterwards shift feature by feature into microservices. So that means the first step for it is to lift existing runtimes into containers, where you keep the data, messaging, and integration where they are, and focusing on the enablement of the development and ops team to deliver value of the new platform. The second step is to slice the functionality by vertical business concern and shift feature after feature into vertical aligned microservices and API. This needs to be done again and again, feature by feature, and at the end, retire the legacy parts when feature parity is attained. I would say this is classical lift and shift. The second approach, what we can see, is the Augment approach. The Augment approach is focused on keeping the legacy intact and enable new capabilities with new layers. In this example here, this would be either a messaging bus or a content router. We have the same starting point of a monolithic stack, where we would keep the legacy parts untouched, but as mentioned, providing the new capabilities on top of it. First of all, what we would do is we would create integration points to expose legacy data and functionality, and new capabilities would be available via so-called pass-through services, which are delivering the new business value. In the second step, you would have to refactor the backend functionality into microservices, and as you would do it as well, as you have seen by lift and shift, rinse and repeat it until the new microservices have again reached feature parity that you can retire the backend. The last approach, what we see is the most intensive, time-intensive approach when it comes to the preparation and planning. Legacy would be totally replaced with the interfaces and data included, and it's using paths to run on it. Some data and features could be rewrapped, but mostly all are retired here. If we are comparing the three approaches, it is quite obvious that a complete rewrite of an application is in most cases the most expensive and longest approach. Depending on your software stack and the business logic, this could take a long time and is really expensive. Lift and shift is, from a migration perspective and duration, the best one. But to be able to lift and shift, you would need to have a well-written application, and it needs to be suitable for containers. In most cases, this is not the case, I would say so. So Augment with new layers is a compromise between both cases, and it does not take the time of a complete rewrite, but in cost of migration, it has some challenges as well. So how can you move on your journey from legacy to cloud native? What you can see here in the pathways, we have three elements. It is always the starting point, an approach how you can do it when it comes to open source and the enablement, what you can use to have it cloud enabled, and for sure at the end, to give you an overview, what is the desired state. For lift and shift, if you have non-open source middleware applications, you could migrate it to the open source stack, and we can help you and enable it on the Kubernetes container engine. The desired state at the end should be a modernized applications with API and microservices in a cloud architecture on containers. For Augment, if you have a starting point that you have a monolithic or a mainframe application that's really hard to change, you should enable integrations to expose the data and functionality using an open source stack. We can support you in the cloud enablement as well in enabling it on the Kubernetes container engine. At the end, as you have seen with lift and shift, you should have a modernized application with an API and microservices in a cloud architecture on containers. The last pathway is the rewrite approach. So if you're having a monolithic application or applications which are on non-open source middleware, which is about to retire, you should architecture and design mapping the old system capabilities to a complete new architecture. How to do that? Set up, train on, and get hands-on experience with Kubernetes container platform. That could be one of the approaches where we are happy to support you. And at the end, you should have the desired state of creating a new set of modern cloud-native applications where you are ready to go fast on the market and innovative. From a methodology and process point of view, that would be, first of all, create a catalog of your applications and do an assessment with the 3 steps. The starting point where the application is to choose the right approach. Analyze the possibility if and how you are able to use open source. Shift if you can do and how you can do a cloud enablement of your application. And afterwards, plan the migration. And the migration should be a logical units or in business containers with the right order to migrate your stack. And with this high-level view on the methodologies and processes at the end of my session, I'm happy to give back the presentation rights to Sebastian, who will talk now about the real-life examples of the things what we have described before. Give us a short moment. So let me stop my sharing. So Sebastian, you should be able to take it over.
Yes, and you should be able to see my screen. Perfect. Yeah, thanks Malte for the explanation, and now let's deep a little bit deeper into real life examples. So what we see there. So one customer, what we had, they had a large scale web application, and so they had a content management, classical e-commerce company. They were running this in a classical way on VMs, on bare metal, or not bare metal, on VMs on their data center infrastructure. They had the problem, first of all, their servers did not scale under load. So for Christmas business, they needed to, or every time during the whole year, they had the capacity to manage their Christmas business. But they also had the challenges, if they really start scaling it, they run into problems because the software was not really built for scaling it. They needed to do a lot of manual steps to really scale this up. So they really needed to plan this quite in advance before. What are the steps to scale this? And they also had the challenge that they had different development environments, like classical development, staging, production. And with this, they had two different lines of this. One was every time blocked by hot fixes, or for hot fixes. So at the end, they really had only like one environment. So before the developers really could test things, they all needed to merge everything into one branch, and then it was deployed. And so it was really hard to build up different environments for the developer. And what they then started to do with us was starting containerized components out of this, so that they easily can deploy the small containers at scale, but that they also can leveraging their CI/CD to orchestrate their containers, and that they easily can set up a new development environment, so that each developer was able, for a specific feature, for example, spinning up a dedicated environment to test this, to provide this to their business and say, hey, is this a feature, or is the feature implemented as you would expect it? And with this, they were really scalable. And so the result was really that they could handle their Christmas or pre-Christmas business loads at scale without any breaking changes, and that they could easily scale this up, that they not need to occupy before a lot of servers for only 2-3 months in the year. And also now, as they have this capability to quickly scale, even if they do advertising on television, for example, they quickly could, before it goes online, they could scale the infrastructure up and afterwards quickly scale it down, and could really also improve their whole DNS setup, and really developers could take over ownership of this, how they could deploy, update, and also roll back features, because potentially it's not working, or it has a bug, or that the feature is not really as expected and used from the end users. And so now they have much more capabilities and can develop much faster on a much higher speed on their system. And the end result was they migrated everything away from their existing data center into the cloud, and running most of the stuff completely containerized. For databases, for example, they use managed services, and have now a really scalable and flexible environment. Another customer, they had a legacy middleware with huge data, and the problem was that the data and the functionality was closely coupled. So each user sessions ended up into a database connection, and So the database was every time really under pressure, and it got more and more complex to add new features to this. And so in this approach, what we did there with the customer, really implemented a new microservice layer between the existing stuff and the end user facing environment, so that they could implement a caching layer to really avoid the expensive database hits. And so from the first day on, their new services was containerized, and that this environment could talk to their legacy, and now they can move more and more of the workload from the legacy stuff into the containerized application, and implemented a new messaging backbone, which they now are using, so to get rid of their existing environment in that way. And so the result was they could really handle much more requests. Before this, they were only able to manage less than 50 concurrent requests. Now they can scale up to 5,000 concurrent requests and even more. And now they could easily expose also functionality to new channels. So for example, before that it was only a website. Now they were able to build a mobile site. They could connect it with their Salesforce. They can connect it with their partner channels, and without having the requirement to really build, do massive changes on their environment. And with this, they really had the benefit that they not had a big bang rewrite upfront to get to this environment. They could now move more and more stuff and really start enabling a DevOps approach. So having new functionalities in that way, but containing their existing legacy, and new features are developed in the new way, and now more and more of the existing features are re-implemented, so that less and less functionalities are running on the old stack, and so that in the future they can completely decommission the old stack. But let's talk a little bit about how you can do this and what are methodologies to go that way. So what we discovered is really, especially if you're not only having one application, if you have multiple applications, tens, hundreds applications you want to migrate, I think it's really important to think about how you can build a repeatable framework inside your organization, so that not every application needs to figure out how do I migrate my workload, and figure out all the heavy steps on its own, so that you can give some best practices and how you do this so that they easily can scale. And with this, you easily can convert several hundred applications or hundreds of applications in a year with a standardized approach. And what we typically do is, like, first starting with a discovery approach. In this, we really explore and analyze the existing infrastructure and figuring out what applications are running. Are they all from the same stack? Like, are this all, for example, Java applications, or is it like a lot of different kind of applications? Java, PHP, potentially Windows applications, even more older applications like AS400 or mainframe applications, things like this, to really get a good understanding what kind of applications you are running. And then building first a list with, like, identifying the applications which are the quick wins on both directions. Quick wins on bringing value to the business, but also quick wins on what are easy to convert. So our recommendations typically start with easier application and not with the biggest and complex one. And then if you have more and more experience, then you can go more and more to the complex one. And so then as the next phase, we're going into a design phase, and there we do 4 different steps. First, analyzing the existing application. Can it easily be containerized? If yes, perfect. So then we can do this. And but if not, what could be approaches how to containerize it? So do we need to completely rewrite it, or can we build a layer in front of this? So next step is then really prove our ideas, what we analyzed, building a pilot, and then building also a migration strategy, so that we really know how to migrate this. And in best case, during the discovery and design phase, we can discover patterns, so that we can say potentially if you have 100 applications, 20 or 30 of the applications are from the same kind, and the ways how we're doing it, we do it when we do it now once, we can apply the same to multiple applications. So all the learnings and all the investments we do for one application, we can later leveraging. And for the first potentially application, we even spend a little bit more time to make it more advanced. But then for the next, we can do it much more quicker, because we can use the same principles and can migrate really fast, and can really start scaling the migration, so that you can move more and more workloads into a cloud native way. And during the discovery phase, it typically takes 1 day to discover. Of course, it's our expert, but we also need your support on this, getting information from you, your business, how to do what applications you're running, and then really going into the later, if everything is planned, into the deploy phase. So typically starting with one application, but what our recommendation then is, if you have multiple applications, typically building something like a center of excellence, having a small team who knows how to do this, and then helping the individual application owner and business owners to really migrate fast, building a knowledge base, so that this center of excellence can be really the team who helps driving other teams to migrate, and so that other teams can quickly migrate, and leveraging the knowledge base you build in-house, and also if there are new challenges, that this knowledge which is built in the specific team is going back into the general center of excellence and in the knowledge base, so that other teams can really participate from this, and so that you can quickly gain speed on how to migrate, in what way to migrate, and be successful on the migration side. Yeah, and that's it from our presentation. And now we would come to the questions. So if you have any questions, feel free to put it into the chat, and happy to answer those questions.